Have you ever wondered why GNSS professionals use different positioning methods for different applications? In the world of high-precision positioning, three methods dominate the field: Static GNSS, RTK GNSS, and PPP. Each can deliver highly accurate coordinates, but they are designed for very different purposes. So which one should you choose? Let's find out. Static GNSS is the traditional high-precision positioning method. Two or more receivers observe the same satellites simultaneously for extended periods, often ranging from several minutes to many hours. The observations are then processed later in the office using specialized software. Because of these long observation sessions and rigorous processing techniques, Static GNSS can achieve millimeter-level precision. This makes it the preferred solution for establishing national geodetic control networks, monitoring tectonic plate motion, measuring structural deformation, and supporting scientific geodesy projects. When the highest possible accuracy is required, Static GNSS remains the gold standard. RTK, or real-time kinematic positioning, takes a different approach. A base station with known coordinates continuously calculates correction data and sends it to a rover receiver in real time. The rover applies these corrections instantly and computes centimeter-level coordinates in the field. Unlike static surveys, there is no need to wait for post-processing. Results are available immediately. This makes RTK ideal for land surveying, construction stakeout, GIS data collection, machine guidance, and drone mapping applications. RTK may not reach the same level of precision as long-duration static observations, but its ability to provide accurate coordinates instantly has made it one of the most widely used GNSS techniques in engineering and mapping. The third method is PPP, or precise point positioning. Unlike static GNSS and RTK, PPP requires only a single receiver. Instead of relying on a nearby reference station, PPP uses highly precise satellite, orbit, and clock corrections generated by global monitoring networks. This allows users to achieve high accuracy positioning almost anywhere on Earth. PPP is particularly valuable in remote regions, offshore environments, polar areas, and locations where establishing a local reference station is difficult or impossible. Traditionally, PPP required a convergence period before reaching its highest accuracy. However, new developments such as real-time PPP are reducing convergence times and making the technique increasingly attractive for operational applications. So which method is best? The answer depends entirely on the task. If your goal is the highest possible accuracy for scientific or geodetic applications, Static GNSS is often the preferred choice. If you need centimeter-level coordinates immediately in the field, RTK is usually the most efficient solution. And if you need high accuracy without access to a nearby reference station, PPP may be the ideal approach. There is no single best GNSS positioning method. The right choice depends on your accuracy requirements, infrastructure, project objectives, and operational constraints. In future videos, we'll explore Static GNSS, RTK, and PPP in much greater detail. Subscribe to GeoGM and turn on notifications so you don't miss future videos about GNSS, Earth monitoring, and geospatial technologies.